Welcome back. Today we're doing properties of logs and exponents. This is page 2. So we're going to start just by reviewing the properties of exponents and how they work. The first one we have the power of 0. So anything raised to the power of 0 equals 1. The second one, we're dividing. So when you divide, you keep the base and you subtract the exponents. Next, we are multiplying. So they have the same base. You keep the base and you add the exponents. Now the next one, if you have a power raised to another power, you multiply the exponents. So you keep the base and you multiply the exponents. Now, negative exponent means reciprocal. So if this was just a whole number, that's going to end up being in the denominator. So if you have a fraction, let's say, I don't know, 2/3 raised to the power of -1, the reciprocal of that is just 3/2. When you have two bases raised to that one exponent, it's like you're distributing the exponent, but not really. You still have a power raised to another power, and in this case, they both have exponents of 1. So A, 1 times m is just m, and b to the power of 1, 1 times m is just m. But if you want to think about this as a distributing the exponent for both of them, that's fine too. Okay, so logarithms represent exponents. So the rules are similar. So how can we relate those? So the first one, we had the power of 0, so everything raised to the power of 0 equals 1. And I also know the base is always the base. So if I were to change from exponent to log, I have log base b with the argument of 1. So log base b of 1 equals 0, because I know I can go backward and do b to the power of 0 equals 1. And that's that first property right there. So the next one we're going to compare the division of exponents will be very similar to when you're dividing with logs. So log base b of m over n. So if here, when you divide, you subtract the exponents, here is not going to be any different. So when you divide the argument, you're going to subtract them. So log base b of m minus log base b of n. Okay? So when you multiply, you add the exponents. Same thing you do when you're multiplying the arguments of a log function. So you're going to add the arguments. So log base b of m plus log base b of n. The next one, when we have log base b of an argument and you have an exponent there, that exponent is going to go in the front, multiplying the whole log. So you're going to have m times log, m being any exponent that you have there. So log base b of a. And this m is multiplying the whole thing. The next one, we have negative exponent. So we're going to make it similar to log base b of 1 over b. That equals -1. So when you double check, you have b raised to the power of -1 equals 1 over b. So that's how you double check that. And the easiest one of them all, I have log base b of b equals 1. So if you want to write yourself a little side note here, when the base and the argument, when the argument are the same, then that equals 1. Base and argument are the same. That equals 1. And that's the end of page 2.